All right, everybody, welcome back to the next video. Today, we're going to briefly discuss inflation restriction. So what does that mean? Well, what does inflation and restriction mean separately? So let's let H be a closed normal subgroup of our group G. And let's suppose X is a G module. Okay, so G is just acting on X here. And we can see then that X to the H, so the stuff in X fixed by H, is a G mod H module in the obvious way. Okay, so definitely G mod H acts on the stuff in X fixed by H. So we can regard a cocycle for G mod H as a cocycle for G via inflation, simply by composing with the standard projection map from G to G mod H. So remember, cocycles for G mod H are essentially special maps from G mod H to X. So what we're saying is that special maps from G mod H to X can also be viewed as special maps from G to X by composing with this projection map here. Okay. Okay, so we can regard cocycles for G mod H as cocycles for G, but we can also regard cocycles for G as cocycles for H just by restriction, just restrict the cocycle, right? So instead of thinking of your special map as a map from G to X, just think of it as a map from H to X by restricting from G down to H. H is a subgroup of G after all. Okay, we also can see that G mod H acts on H1 of HX by G acting on F of H is G times F of G inverse HG, where F is a one cocycle and G represents a coset in G mod H. Okay, that's just kind of a thing to check. This action is well defined. I mean, you have to make sure that if G prime is another representative of the coset of G, then G acting on F and G prime acting on F differ by a co-boundary because H1 is cocycles mod co-boundaries. Okay, so you have to actually check this, but it's a quick check. So what is inflation restriction? Proposition 2, there's an exact sequence from 0 to H1 of G mod H X to the H to H1 of GX to H1 of HX, the stuff in there fixed by G mod H, to H2 of G mod H, X to the H to H2 of GX, okay? And so if you want a proof of this, there's a bunch of places that prove this, like Sayre proves this in his books, but also if you want a proof that defines the connecting maps, just kind of a standard reference is Schatz's book, Pro-Finite Groups, Arithmetic and Geometry, which I'll call SPGA if I ever refer to it again. I think that's in chapter 2 there. Okay. Inflation here. Then we restrict down to H. So this is kind of like restriction. Then we have a connecting map going up to H2, and then we sort of start over again. Okay. So it's like inflate, restrict, connect, start over, basically. Okay, so let's look at a quick example here. So let's let P be a prime and let's let G equal the local Galois group at P, so G sub QP. Let's let H be the inertia group I sub P, which is just the Galois group of QP bar over the maximal unramified extension of QP, which I'll call QNR sub P. We've already seen long ago that GP mod IP is isomorphic to the Galois group of FP bar mod FP. And so what does the first part of the inflation restriction sequence show? It shows that H1 of GP mod IP X to the IP is isomorphic to the kernel of the map from H1 of GPX to H1 of IPX. And so what that means is we can regard this guy here, H1 of GP mod IP X to the IP, as a subgroup of H1 of GPX, whose elements are the cohomology classes that become trivial when restricted to inertia. In other words, they're in the kernel of this map. Okay. We call these the unramified classes. I mean, that shouldn't surprise you. Trivial and restricted to inertia, that's always meant unramified since the beginning of this lecture series. Okay, so as an example, within an example, let's let X equal Z mod 2Z. Let's just keep it simple. What are the unramified classes here? Well, they're the homomorphisms GP to Z mod 2Z, which are 0 and IP by this discussion we just had. And these can, of course, be identified with homomorphisms from GP mod IP to Z mod 2Z. And there are only two of these, the trivial map and the one corresponding to the unique unramified quadratic extension of QP or of FP, if you like. I don't know, this whole thing about these corresponding to field extensions, which we already talked about in a previous video, but also the fact that there's only a unique unramified quadratic extension of QP. This is all covered in like a standard number theory book like Neukirch or something, okay? Actually, all the part of this discussion follows from the next lemma, which I'll conclude with. So lemma 1, let's let X be finite, then the cardinality of H1 of GP mod IP X to the IP is the same as the cardinality of H0 GPX. So there's kind of like a little bit of duality going on here between this H1 and this H0. And this quantity is finite also. Okay, the proof is easy, so I'll just give it. So basically, it's easy to check. There's an exact sequence from 0 to x to the GP, to x to the IP, to x to the IP, where the map here is frob minus 1, okay, Frobenius minus 1, to x to the IP mod frob minus 1, x to the IP to 0. And it's clear that this is exact everywhere except maybe here at this first x to the IP. But we are exact at the first x to the IP because if x is in x to the IP and frob minus 1 of x is 0, in other words, if I'm in the kernel, if I'm here and in the kernel of this map, then x is fixed by IP and frob, but those topologically generate GP, okay? So I'm in the image of x to the GP, so I'm effectively in x to the GP, okay? And so the image here is the same as the kernel here, and so I'm exact, okay? So, but the key point is the first term in this exact sequence here is just H0 GPX by definition, right? And this last term, by facts we've discussed in this video and in previous videos, is just H1 of GP mod IPX to the IP. Okay, well then these definitely have to have the same cardinality, right? Because this last guy here is isomorphic to this mod image of this, which we just got done discussing, is this. Okay. Okay, well, if these are isomorphic, then they have the same size, right? So, okay, and why is the quantity finite? Well, I know x is finite, and I know this guy here is the size of x to the IP mod something. Well, x to the IP just lives in x, which is finite. When I mod out, I have even less, okay? And so next time I'll be discussing the cup product briefly. So thanks for watching, and I'll see you then.